Hello, Physics 30s. I just want to make a quick note on polarization. Polarization is kind of a fun concept. It does not have any math for our purposes. All you need to understand is that light normally vibrates in multiple planes, or it can vibrate in multiple planes. So as you can see here on this, it tries to show we could be having light rays going up and down, and in all directions like that. Okay, so you get the idea. That's what that graphic tries to show. So if that's the case, we call that unpolarized. So it's unpolarized light. It's light that's just reflect or bouncing or traveling as a transverse wave in multiple directions. We can apply filters to that light, though, and in a very clever way, as you may have seen in that video. The videos I posted are actually really, really good. The main thing that's curbed by polarized filters is glare. And excuse me, in this picture here, as you can see, the sun is shining, and those rays of light could be bouncing in in these two planes. Obviously, they'd be going in infinite planes. There is a little bit of compression in the vertical plane when light hits, say, the surface of water or something. And that's what this sort of shows right here, is that the vertical plane gets compressed a little bit, kind of like I don't know, you can imagine like a basketball or a tennis ball being squished a little bit when it hits the surface. Don't worry about that too much. What I wanted to show is that this device right here is a polarized filter. And in a polarized filter, either certain structures within it or the coating on top has vertical slits in it. So what will happen is only the light that is parallel to those slits will pass through. Everything that's at a different angle will be reflected. And so if we look behind what would have happened here behind this, and I didn't end that, but behind the filter, you will only get light that is vibrating up and down. The horizontal light will hit the filter and it will reflect. It will bounce back because it can't pass through the slits. Okay, and polarizing is very helpful, obviously for reducing the amount of glare, but for eliminating unwanted light. And that's what these last pictures attempt to show. So you can take a filter, and actually I happen to have one here that I'll maybe try and show it on the screen, because if you take just your phone and this here is a filter. You can see, if it looking at it through, you can see me through the filter. It doesn't seem to change. Actually, it maybe does a little bit as I rotate. It might get a little bit dimmer. If I come over here, the image behind me is a little bit dimmer. But if I'm looking at this here, I can actually get some slightly different colors to appear. And see, I go from green there to, I don't know if I can keep it in there. Keep it a little bit of a purple. So this here is a polarizing filter. It's used on cameras. And even you can tell that as you see my face, it's darkened just a little bit at a certain angle. At another angle, it maybe doesn't. It doesn't block as much. So anyway, if you have two of these filters, that's what this picture shows down here at the bottom. That if you orient them so that both of them have their slits in the same orientation, then basically the light will still pass through. But if you orient them at 90 degrees, so one could have its slits this way, the other one could have its slits that way. And as soon as you do that, effectively you can block out the light. And it's kind of fun to try. If you're wearing polarized sunglasses, that's something you can try sometime. Have your phone on and then look at it through your polarized sunglasses. And often the light that comes out of your phone is already polarized. They've already designed it so that they get maximal output of light. and it's also coming through a bit of a glass screen as well. So depending on your phone, you can actually make parts of it disappear depending on what kind of what kind of polarized filters you're using. So all you need to know is that light can be polarized, and that's evidence that it is a wave.